Hey, this is Steven from LegitTechTutorials and welcome back to my product development series. Today we are back working on the DIY metal mill. This is New Year's Day, or not, well, so New Year's Eve was yesterday. Today is 1/1/2018. I was thinking about starting this over back in 2017 when I was on vacation in Oregon, but I didn't really have a chance to myself in a nice quiet room. Well, I did, but I was super busy. Could have went into Grandpa's garage, but decided not to. So I decided just to take that time off with my family. So we're going to work on this, and hopefully I get. I definitely want, because originally it was supposed to be before yesterday. I wanted to have an order in. Actually, before Tuesday last week, I wanted to have an order in. But we're going to try to finish this up by Sunday of this week here, and see if we get that ordered, and then in the meantime after that clean up the garage, get it ready to receive, and then after we design the mill we need to design the enclosure. Then I need to buy the plastics, get the plastics cut, and then whatever I'm going to use to hold it. So by Sunday, by Friday actually it would be ideal. By Friday have it designed and ready to go, ready to buy everything and have everything come from China, preferably locally, so it doesn't take so long. So preferably within Friday, next week Monday it ship out, and then hopefully I would get it by that the next Monday after that. So I would have a week plus Saturday Sunday to clean up the garage, as well as design the enclosure to keep all of the liquid inside. Alright, so we have some of the stuff from the DIY. I'm also a little tired from traveling because we drove up to Oregon, so it was a 9-hour drive back. So a little tired from yesterday. Even though I felt like I got plenty of sleep last night, I was still a little tired. So, okay, so here we have a few specs of what we have to go around. So the cubby is 23.75 wide, like 28.5 long, and then 17 inches tall, which can be adjusted. So you could have it drop it down so that it'll fit better inside the cubby, and also bring the next one lower, because what I would like to do with the next one is I would like to have a laser, put a laser in there. So maybe have it adjusted, but have pretty much adjustable, but have everything low. So maybe if I want to do some milling, I could pick up the shelf and move it upwards, and then maybe have, you know, a way that I could bring up the enclosure, or maybe have, you know, the enclosure a certain size. Because for the most part, this is probably not going to be the best for a mill because of the speed. It's going to be best for a router and doing full slotting and stuff. Everything once you get too big of a end mill, it's going to be pretty hard to do anything like that. So for example, like you know, doing surfacing or anything like that with the shear hog or whatever, it's definitely not a good idea to run that 18,000 RPM. This is probably only going to be for a router, because so I would like to bring that shelf that's above it down, so that I could put a you know, Chinese laser that I'll modify in there. So that's the idea. Okay, then we have the 20mm linear rail, 20mm diagonal, and then 2 carriages per rail, so total 4 carriages on the X, 4 carriages on the Y, and then 4 carriages on the Z. And then those lengths are so 16mm diameter ball screw, and those two come in a 350, 650, and 1050 all in one pack. So these are all in one pack. 350, 650, and 1050 for both the 16mm diameter ball screw and the 20mm linear rail. And then a 2 horsepower spindle, otherwise known as 1.5 kilowatt, because we have 750 watts per horsepower, with a 1.05 millimeter maximum runout. Preferably air cooled, so I don't have to deal with that. But what I could do is have it water cooled, and it would just have a like a what is it called, like a mesh there, and then basically feed the coolant through it. Pretty much what I might do is have everything inside that box and just have it feed coolant through it, and then out the other side maybe spray warmer coolant on the end mill, so maybe we don't have so hot of liquid that it shocks the end mill too much. So it keeps the end mill at a nice hot temperature, but the differential between the two isn't so drastic. So you're not spraying like really cold water on a really hot tool, you know, it might I'm curious. I've never seen that done before, where the fluid's actually heated. In this case, it's heated by, you know, the inefficiency of the spindle, because it's going to be, you know, coming out as heat. So spray that on the tool instead of cold water or cold fluid water mix, right? And then maybe that won't shock the tool as much and cause any sort of cracking or something like that. Okay, running on gerbil, NEMA 17s. I don't think NEMA 17s are probably the best idea, or this is supposed to be NEMA 17s, not 16s. So maybe we'll design it for NEMA 23s. Need power supply 12 by 36 volt DC. Pump water, metal for frame, A36, plastic for box. Mister with pump. Definitely need a mister. So basically that idea would be, if it was water cooled, pump the fluid up through the spindle, and then out the output of the spindle, and then down to the mister. Right. And budget $700 to $800. Okay. So you guys remember on the last video the idea that we had for it. So the options I showed, the kind of like what it would look like. So we're going to have a flat plate for the table, right? And then underneath we're going to have the rails mounted, right? Rail here, right? And then those rails are going to have the carriages, and then we're going to have a piece that goes up, and then up, all the way, one solid piece, right? Solid here, welded on the sides. And then it goes up and attaches across with a back piece to keep it sturdy, and then have the two rails going across there, and then have the upright with two rails. So the idea again is, when we design this, we need it to be designed to where I only have drill press. I don't have a drill press. I have a drill. I only have a hand drill. A portable bandsaw, which is not great for straight cuts, and for straight cuts I have a hot saw. So I pretty much only have a hand drill and hot saw. Maybe might have access to a mill and a lathe, possibly. So if that's what we got, we have to work around that and possibly get some pre-built parts. Okay, so let's go ahead and start out with our first piece. So in here, let's do layouts. And then we're gonna have a main layout. But this one's going to be our base plate. Okay, so base plate, again with those dimensions. I shouldn't have deleted that. Oh, okay, I didn't. Okay. So 23.75 by 28.5 by 17. So let's just say we give it a quarter of an inch. So half an inch at least. So that's like 23 by 28. So here we go. Dimension with D key. And I believe it's this way, 23. Yeah, it's wide. 23 point. I'm going to say here 23, reason being is that there's actually like a face frame on it, and so we might need to be a little bit smaller. Like 28. So this is fine because there's no face frame here, so we needed to fit inside the face frame. Okay. Or you can take the face frame off, put it in there, put the face frame back on there. So this may or may not change. Okay, so here's the basic base plate, and then we'll have a few mounting holes, for example, but these will be added probably by the machine after I mount the machine on there. So we have that, and so let me pull up an example for some of the rails that we're going to put on there, and then we're going to take a look at maybe some of the drawings that they have on it. And hopefully we don't have to buy it to look at the drawing that we're trying to do, to look at the to get the basically the bolt pattern, how the bolts are laid out. Everything is really slow right now. Okay, here we go. It's loading. It's just loading really slow. Okay. Okay. This one right here. Okay, so this just has screws periodically. So maybe we won't have it drawn. So maybe we'll just have to measure it when we get it and then add the drawings later. Because what I would like to do, but this is definitely aluminum, I would like to weld it on there. So maybe I could find some CAD drawings for it. So I'm looking for the screw hole points here. So here's P. Okay. P distance. Okay, so there's 100 millimeters apart. And the start one doesn't really say where the start one is. But yeah, basically 100 millimeters apart. And I believe that these are indeed aluminum. Well, the main bar is steel, but I think the body might be aluminum. So SRB 20P is 200 on this one. Huh. Anyways, so let's have it like that, and then let's save this, save that, and then let's pop it up. But what we can do is we can have the overall base, but we'll draw that on top. So let's say right now I'm gonna guess to get it a little bit more flat, because I've worked with a quarter inch. Quarter inch isn't exactly perfectly flat. So now if I go here and I add a material to the body, physical material of A36 steel. Oops. Metal. I think it's at the very end. Okay. What is that weight? That is 1095 divided by 16. It's almost 70 pounds. This thing's probably going to weigh about 100 pounds. Okay. So maybe we'll try to adjust that, but right now that's fine. Okay. So now, then here it's saying that B on SRB 20, B's up here. Where's B down here? B's up here. SRB 20, B is 45. Okay. So all the way down, and then this is 45 millimeters. So that's one rail there. And then the question is how oops, whatever. The question is how far over do we need that to be? We'll do some analysis on it later on to figure that out. Okay, so let's go ahead and save that. Let's pop open a new one and let's draw this SRB 20s. Okay, so here we have all the measurements So what I think I'm actually going to do is save this image. Oops. So I could copy it pretty closely. Let me open. So what I'm going to do is I'm going to open this in Paint, and then I'm going to basically cut it. Do some select. Then I'm going to crop that, file save. To my Dropbox. Dropbox. Okay. That's fine. Okay. So now we're going to look at one of these dimensions, which I'm probably going to go back to the original picture. Original picture's a little bit better. So obviously, well, this rail is obviously 20 millimeters. So we could do that right now. And then all these should be to scale, but we could double check. This should be to scale. It actually might not be. It's possible. It's possible it might not be. Oh, so what we're going to do for canvas is we're going to calibrate it here to here. This is 20 millimeters. Okay, so let's double check. Okay, so SRB 20, so let's look at one of these dimensions. Okay, thickness, or height, let's see. Height, E, X, Y. Well, we could look at Y. Y is from there to there, which Y on SRB 20. Y is 10 millimeters. So let's change this to millimeters first. No, this is not right. Okay, well at least you know we could sort of go off it, kind of, sort of, maybe. Okay, let's move this canvas. So this guy is in the center, as close to center of mass as possible. That looks good. Okay. Okay, so on SRB 20, E is SRB 20, E is 22.5. Yeah, it's off. Okay, well, let's do something like this. I don't know what that is. Okay. Collinear. something like that, something like that. It's a good approximation. Okay, so now we sort of have that detailed, and as you see, there's a hump here. It's not exactly, connected there at the bottom, which is kind of dumb. Why it's so small like that? It only has this thickness that attaches and this other thickness here. Okay, so let's go ahead and resize this. So the T for SBR is 5. So from here to here is actually 5. That's what I thought. Okay, so this is what I'm going to do. Oh, and then do they have a general height from? No. Well, they have that and Y. So let's see if I can do collinear. Make this horizontal. So what I should have done is had this from the bottom. So let's go ahead and let's delete this and then do it from the bottom. So E on SRP 20, or no, T was 5. T is 5. Okay. And so let's delete this one. Oops. Okay, that's why it looks a little small. Okay, and then H from here to the top is SRB 20 is 17.7. Parallel. How is it over constrained? Anyways. Whatever. Okay. And then F is basically the distance from this one to this one. It's 19. That's pretty close already. And you're supposed to sort of split the distance, but whatever. It's 1 millimeter off. Okay. And then from the center all the way to the bottom is H. Lowercase h. From the center all the way to the bottom, lowercase h is 27. Yeah, so we're there. Has to be kind of like that. And then this is a 60 degrees. And then this one here is this distance. This distance minus this distance, right? No. Oh, there you go, Y. Big Y. Big Y is from here to there. Big Y. Big Y is 10. Big Y is 10. There we go. There we go. Let's put a point right in the middle section. Oops. Oh yeah, does it have a overall length is B, which is 45. Wow, it's short. Well, 45, so I could do, instead of doing this, and then this F is 19. So here. I don't understand how this could be in a different spot. How is that over constrained? Okay, we need to get rid of some stuff. That needs to be there, that needs to be there, that needs to be there. Where is it over constrained? Is this? That's probably this. No, still over constrained. Still over constrained. Maybe if I make these two equal to each other. There we go. then Y is supposed to be, no, F. F is 19. Yeah, that's pretty close. It's pretty close. That's fine. It's pretty close. Just make sure these are parallel to each other. This one's parallel. Okay, it looks like it is. Okay. Let's go ahead and stop that. Okay, so now we need to let's go ahead and save this as okay, let's go ahead and extrude. So we have a few of these. We have the 600 millimeter, 350, okay. Then we have the 650. Oops. And we have the 1050. Okay, that's it for this video. We'll start again here in a few minutes. I might upload this. Okay, so now on for this year and forward, I don't think I'm gonna mess with you know, modifying the videos. Actually, I have to because the sound, the buzzing sound might be really annoying. I might have to fix the buzzing sound of my computer. There's a fan in there wrong or something. Because what you'll hear is a lot of buzzing. So what I need to do is I need to change it so that I could just have it where I could just upload the video. So this one might be buzzy, but what I'll do is I'll listen to my mic. I'll change the gain so that you can't hear the buzzing in the background. Because I have the computer underneath the table right now, but you probably still hear it because it's an omnidirectional mic, and I guess it's sort of headed to the facing the way of the computer. So what, and also normally what I do is I cut out the bottom as far as the date and time, but I'm just going to upload it straight now because otherwise I would have to go into Premiere and do a dehummer and do a crop and crop this out and crop that out, and it just takes time, you know. I'd rather just straight upload it because now it takes like maybe about half with my new 1060 and using the encoder on board to start to crunch, start to encode the videos. It still takes about half the video length, so it takes about 15 minutes to set it up. And then I need to spend another, you know, 15 minutes to upload it. But back in the day, you know, when I had my 660, which now my roommate has, it would take me the time of the video to upload it. I mean, time of the video to encode it. So 30 minutes plus 15 is 45 minutes. So what I might do, I'm just going to upload this one straight, and then while it's uploading, I'm going to listen to my mic here and adjust the gain, so I don't have to basically encode the video every time. I could do it where you just can't hear the humming, and then don't worry about the crop. Okay, this has been Steve from LegitTechTutorials. I thank you guys for watching. If you like this video, please subscribe for more videos like it in this series and our series as well. See you guys in my next video. Thanks for watching. Take it easy. Peace.